Good morning, viewer. Biandasya. Yes, breaking news. Yeah, NASA researchers have found that amino acids, potential indicators of life, could survive near the surface of Europa and Enceladus, moons of Jupiter and Saturn, respectively. Experiments indicate that these organic molecules can withstand radiations just under the ice, making them accessible to future robotic landers without deep drilling. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, have evidence of oceans beneath their ice crust. Yeah, a NASA experiment suggests that if these oceans support life, signatures of that life in the form of organic molecules, that is, amino acids, nucleic acid, etc., could survive just under the surface ice despite the harsh radiation on these worlds. If robotic landers are sent to these moons to look for life signs, they would not have to dig very deep to find amino acids that have survived being altered or destroyed by radiations. Based on our experiments, the safe sampling depth for amino acids on Europa is almost 8 inches, around 20 centimeters at high latitudes of the trailing hemisphere. Hemisphere means opposite to the direction of Europa's motion around Jupiter, in the area where the surface has not been disturbed much by meteoroid impacts, said Alexander Pavlov of NASA's Goddard Space Flight Center in Greenbelt, Maryland, lead author of a paper on the research published July 18 in the journal Astrobiology. Yeah, subsurface sampling is not required for the detection of amino acids on Enceladus. These molecules will survive radiolysis, that is called the breakdown by radiations, at any locations on the Enceladus surface less than a tenth of an inch under a few millimeters from the surface. The frigid surfaces of these nearly airless moons are likely uninhabitable due to radiation from both high-speed particles trapped in their host planets, magnetic fields, and powerful events in deep space, such as exploding stars. However, both have oceans under their icy surfaces that are heated by tides from the gravitational pull of the host planet and neighboring moons. These subsurface oceans could harbor life if they have other necessities such as an energy supply as well as elements and compounds used in biological molecules. The research team used amino acids in radiolysis experiments as possible representatives of biomolecules on icy moons. Amino acids can be created by life or by non-biological chemistry. However, finding certain kinds of amino acids on Europa or Enceladus would be a potential sign of life because they are used by terrestrial life as a component to build proteins. Yeah, proteins are essential to life as they are used to make enzymes which speed up or regulate chemical reactions and to make structures. Amino acids and other compounds from subsurface oceans could be brought to the surface by geyser activity or the slow churning motion of the ice crust. Amazing. Behind this exclusive report.